Scrubbers or exhaust gas cleaning systems are used to remove particulate matter and harmful components such as sulfur oxide and nitrogen oxide from the exhaust gases generated as a result of combustion processes in marine engines to implement pollution control. These scrubbing systems have been developed and employed to treat exhaust from engines, auxiliary engines and boilers on shore and on board marine vessels to ensure that no damage is done to human life and the environment by toxic chemicals. Compliance with the new regulations requires that vessels either use expensive fuels with low sulfur content or clean the exhaust gases by using exhaust scrubbing systems. Exhaust gas scrubbers are installed on a substantial number of ships to comply with international regulations and standards economically. Exhaust gas streams are passed inside the scrubber, where an alkaline scrubbing materials is presented to neutralize the acidic nature of the exhaust gases and remove any particulate matter from the exhaust. The used up scrubbing material is then collected with the wash water, which may be stored or disposed of immediately as the effluent. The cleaned exhaust is passed out of the system into the atmosphere. The scrubbing material is chosen such that specific impurities like sulfur oxides or nitrogen oxides can be removed by suitable chemical reactions. For desulfurization purposes, marine scrubbers use lime or caustic soda such that sulfur-based salts are produced after treatment, which can be easily discharged as they do not pose a threat to the environment. Scrubbers may use seawater, fresh water with added calcium sodium sorbents or pellets of hydrate lime as the scrubbing medium because of their alkaline nature. To increase the contact time between the scrubbing material and gas, packed beds consisting of gas pollutant removal reagents such as limestone are used inside the scrubbers. These packed beds, they slow down the vertical flow of water inside the scrubber and intensify the exhaust gas cooling and acidic water neutralization process. Scrubbers are designed to maximize the absorption of gases passing through it. On the basis of their operation, marine scrubbers can be classified into wet and dry scrubbers. Dry scrubbers employ solid lime as the alkaline scrubbing material, which removes sulfur dioxide from exhaust gases. Wet scrubbers use water which is sprayed into the exhaust gas for the same purpose. Wet scrubbers are further classified into closed loop or open loop scrubbers. In closed loop scrubbers, fresh water or seawater can be used as the scrubbing liquid. When fresh water is used in closed loop scrubbers, the quality of water surrounding the ship has no effect on the performance and effluent emissions of the scrubber. Open loop scrubbers consume seawater in the scrubbing process. Inside the wet scrubber, the scrubbing liquid used may be seawater or fresh water with chemical additives. The most commonly used additives used are caustic soda, sodium hydroxide, and the limestone, calcium carbonate. Scrubbing liquid is sprayed into the exhaust gas stream through nozzles to distribute it effectively. In most scrubbers, the design is such that the scrubbing liquid moves downstream. However, scrubbers with an upstream movement of scrubbing liquids are available as well. The exhaust inlet of the scrubber can be made in the form of a venturi in which the gas enters at the top and the water is sprayed in the high exhaust gas speed areas at the neck or above the neck in the form of spray. The exhaust intake is either on the side or at the bottom of the tower. The designs ensure that the sulfur oxides present in the exhaust are passed through the scrubbing liquid, reacting with it to form sulfur acid. When diluted with alkaline seawater, sulfuric acid, which is highly corrosive in nature, can be neutralized. The wash water is discharged into the open sea after being treated in a separator to remove any sludge from it, and the cleaned exhaust passes out of the system. Mist eliminators are used in the scrubbing towers to remove any acid mist that forms in the chamber by separating the droplets that are present in the inlet gas from the outlet gas stream. MARPA regulations require that the wash water used has to be monitored before being discharged to ensure that its pH value is not too low. Since the alkalinity of seawater varies due to the number of reasons such as the distance from land, volcanic activity, marine life, etc., wet scrubbers are divided into two types of open and closed loop systems. Both systems have been combined into a hybrid system which can employ the most suitable scrubbing action depending upon the condition of the wedge. This system uses seawater as the scrubbing and neutralizing medium. No other chemicals are required for desulfurization of gases. The exhaust stream from the engine or boiler passes into the scrubber and is treated with only alkaline seawater. The volume of this seawater depends upon the size of the engine and its power output. The system is extremely effective but requires large pumping capacity as the amount of seawater required is quite high. An open loop system works perfectly satisfactorily when the seawater used for scrubbing has sufficient alkalinity. However, seawater which is at high ambient temperature, fresh water and even brackish water is not effective and cannot be used. An open loop scrubber for this reason is not considered as a suitable technology for areas such as the Baltic where salinity levels are not high. It works on similar principles to an open loop system. It uses a fresh water treated with a chemical, usually sodium hydroxide, instead of seawater as the scrubbing medium. The sulfur oxide from the exhaust gas stream is converted into harmless sodium sulfite before being recycled for use. The wash water from a closed loop scrubber system is passed through a process tank where it's cleaned.